All right, my friends. So today we're going to be taking a look at Chapter 7, which is Polynomials. And hopefully this will get us through the rest, or at least a large portion of what's left of the year. So basically today our lesson is vocabulary and format to construct models of real situations, including 2- and 3-dimensional figures, and interpret the special points of a polynomial. So what we're going to be doing is we're going to actually be breaking this lesson into smaller bits. So like we're going to do a portion of the lesson and then that video is going to stop and you're going to go and work on an assignment on its learning. Answer that assignment, then come back and watch the next video. Answer an assignment on its learning, then come back, answer. Okay, so it's going to be a process. So for the first part, we're going to talk about vocabulary, and we're going to talk about identifying some of the items for a polynomial. So first thing we're going to do is this is what a polynomial looks like. Okay, a polynomial is a sub n x to the n plus a sub n minus 1 x to the n minus 1, a sub n minus 2 x to the n minus 2. And I know you're like, thought we were done with these subscripts. Basically, all this is saying is, hey, this is a polynomial, all right? And a polynomial is very simple. It says n is a non-negative number, which means that, where is n? N is our subscripts, right? So our subscripts have to be non-negative integers, and our exponents have to be non-negative integers. So we can't have a negative exponent, and we can't have a negative sequence number. Okay, so however many terms there are, that's what we've got going on here. So a couple of vocabulary words. First off, our degree. Degree is the highest number on x. It's the highest exponent that you see on the power of x. Coefficients. Coefficients are the big numbers in front. Okay, so if we're talking coefficients, this is a coefficient. This is a coefficient. This is a coefficient. This is a coefficient. Okay, they're the numbers in front of the variables. Leading coefficient. The leading coefficient is the number in front of the term that has the highest exponent. It is not necessarily the first one. So what you have to do is you have to look at which one has the highest exponent, and then you have to decide, okay, that's my leading coefficient. So in this instance, here's my highest exponent. So that means that this would be my leading coefficient. I guess that's not a really good color since it blends right in with the background. So my leading coefficient there would be a sub n. So in order for it to be the leading coefficient being the number that's in front of the whole polynomial, you need to rewrite it in descending order of exponents, which we'll talk about in a moment, which is standard form. Standard form is when you are writing your exponents in descending order of exponents. So let me just move this because okay, so and that way we can see everything. Okay, so it's when the polynomials are written in descending order of their exponents, because when I made this flip chart I wasn't planning on being in the corner over here videoing to y'all. So standard form is when the terms of the polynomial are written in descending order. Now there's two different things we can do. When we classify polynomials, you classify polynomials by two things. One of the things you classify them by is degrees. Another thing you classify them by is terms. What are the terms? Well, terms are the things that are being added and subtracted. So this is the first term. That's our second term. That's our third term. Whatever's in here. And then this would be our last term. The terms are what's being added or subtracted. Those are the terms. So we count the number of things between the plus signs. And those numbers of between the plus signs are our terms. So we identify by terms, and we also identify by degree. So we look at the exponents and we decide which one is the highest exponent, and then we use that from there. So let's take a look. So polynomials of degree 0 through 5 have special names. Okay, so if it has a polynomial that's 0 through 5, so this one, there's no exponents here. No exponents that we see, there's no variables. We're looking for a variable, we have no variables. So this polynomial is degree 0, and it's called a constant polynomial. It is called a constant polynomial. It is also only one term. And since it is only one term, it's called a monomial. Okay, so that's just a little something for you extra. So if we were to classify this polynomial, it would be a constant monomial. Okay, that would be a constant monomial. Okay, so that would be a constant monomial. So now what we're going to do, this has one variable. The variable here is x. It has 1 degree, so its degree is 1. Anything that's degree 1, if we were to graph it, it would be a line. So this is called linear. Now, to answer the question, what type of polynomial is it? Well, this happens to have 2 terms. So since it has 2 terms, we call it a binomial because it has 2 terms, just like a bicycle has 2 wheels and a bipod has 2 pods. Okay? For the third one. The third one, well, we have a y and a y squared. So when we're looking at our exponents, this has an exponent of 1, this has an exponent of 2, which is bigger? Well, 2 is bigger than 1, so this would be degree 2. And since it's degree 2, when we graphed it, it would be a parabola, and those are all quadratics. Since this has a polynomial that has 2 terms, this would also be a binomial. Okay, so I switched over there so that hopefully this is how it works. We can see the work that's going on. So now when we look at this one, again, we're looking for degree. So we look at our exponents. We have an exponent of 3. This has an exponent of 1. This has no variables. So our highest degree is 3. So since our highest degree is 3, it's called third degree. And a third degree polynomial is called a cubic. This also happens to have 3 terms. Since it has 3 terms, it's called a trinomial. Hopefully those aren't new terms, and hopefully these degrees aren't new words for you. The next example, looking at our exponents to find the degree, we have an exponent of 4, we have an exponent of 2. So as we're looking at these, which is bigger? Well, degree 4. This is called quartic. And again, it has 3 terms, so it's a trinomial. And lastly, as we look at this and we come up with our exponents, this has an exponent of 5, this has an exponent of 4, this has an exponent of 3, this has an exponent of 1. So this is actually degree 5, and it's called a quintic. Sometimes. Not always used, but it's good to know in case you are, wanting to impress somebody. Anything that has 4 or more terms. So this has 4 or more terms because it has 1, 2, 3, 4 terms. So we're going to call this a polynomial. Okay, there's not a special term for that. It's just called a polynomial. Okay? So there's some vocabulary. Now, what we're going to take a look at here is we're going to try to determine what the degree of this function is, what the leading coefficient is, what's the name of the polynomial, and then we're going to graph it, find the y-intercept, and find all the x-intercepts. Okay? So the first question is, what's the degree? Well, the degree is really easy. Okay? You look at your exponents. We have an exponent of 3, we have an exponent of 4, we have an exponent of 1. What's the largest one? 4. So our degree is 4. Okay, what's the leading coefficient? Now remember we said the leading coefficient is the coefficient in front of the highest degreed term. So in this case, our highest degreed term is x to the 4th. So the coefficient would be negative 2/3. Now, since it is degree 4, what would our degree name be? Right, our degree name would be quartic. And how many terms does it have? Well, it has 4 terms, so this would be a quartic polynomial. Now it says to graph the function on your calculator and find the y-intercepts. Well, we don't have to graph it to find the y-intercept, because the y-intercept always occurs when x equals 0. So if the x's were all 0, our y-intercept would just be 2. So our y-intercept is 2. Then it says to graph this and find all of the x-intercepts. Well, when I graph this, I've got my picture of it on my calculator here, but I can't really see my calculator. So let me go to Desmos. Okay, so here we are in Desmos, and I've just typed my equation in exactly like I saw it on my screen over here. 3x to the 3rd plus a negative 2/3 x to the 4th minus 5x plus 2. This is what I saw when I typed it into my calculator when I made this flip chart, and this is what I see when I look at this flip chart here. So what I want to do is I want to find, it says the x-intercepts and the y-intercepts. Well, my y-intercept is right here, 0, 2. My x-intercepts, using Desmos, this is a blast. My x-intercepts is negative 1.30, 0.4490, 1.2550, and 4097. So those are my x-intercepts. Now, interesting, I have 4 x-intercepts and I have a degree of 4. That's not a coincidence. Okay, if I change that to 2, now my degree is 3, so I have 3 x-intercepts. But it wasn't. It was degree 4, so let me go back. So the number of the degree is how many zeros there should be. Okay, so when we look at this, coming back to our equation, so it says to find the x-intercepts of the graph. Okay, so did I? Nope, I didn't type them in. So we can see them here from our Desmos, and we said that one of them was negative 1.30. And then we had 0.4490. And then we had 12550. And then we had 4.0970. And if you look at our table here, so what happens when we look at the table, so we said that our zeros were at negative 1.3. So between negative 2 and negative 1, we go from a negative to a positive. So there has to be a 0 here. From 0 to 1, we go from a positive to a negative. From 1 to 2, we go from a positive to a negative. From 4 to 5, we go from a positive to a negative. So when you switch those signs, there's where your zeros occur. So that's a good way to narrow it down. So what I'm going to ask you to do is we're going to stop this video. There's an assignment for you to complete. It says test. It's not a test. It's just so that it'll grade it for you immediately, and you'll know whether you got them all right or not. Okay, it's just a little 3-question quizzy quiz. Not really a quizzy quiz. 3-question assignment that I need you to do. Okay? Thank you.